Hello, my name is Jimena Markakis, and today we're going to present you two interesting topics that we saw in class that were Riemann sums and definite integrals. So my team is formed by Yomara Morales, Emilio Pulido, and Sofia Huerta and Oscar Nogales.
George Ferdinand Riemann was born on September 17th of 1827 in Breslauwitz, Hanover, Germany. He was a mathematics whose profound a novel that approach to the study of the geometrically laid the mathematical foundation for Albert Einstein's theory of relativity. Also, he made important contributions to the theory of functions, complex analysis, and number theory.
What is it? The Riemann sum is a type of approximation of the value of an integral by means of a finite sum. They call like that in honor of the mathematical Bernhard Riemann. This procedure is basically used to explain us that in order to find an area of an irregular figure, we must start to divide it into finite number of rectangles. The more rectangle we use, the more precisely the area will be. This is due to the possibility of an error that the calculation may have, and the best way to avoid it is by dividing the area until the error is not a big deal.
Well, hi, I'm going to explain you how to use the Riemann sums method. And the way you use this method, it's like you first have to have a range of the x of a curve, and then you have to divide it in. I mean, if it's 2, you can divide it in 0.5 little lines. So when you divide it like this, you make little rectangles like this, and you get the area of each rectangle. And when you have the area of each of one rectangle, you sum it, and that's how you use the Riemann sums. Now I'm going to give you an example of how to use this Riemann sums. And you have to make the triangles. I want to know the area between 1 and 4 of this graph. So I divided in 3 rectangles. So I get the area of each triangle and sum it. 6. The value of this integral from 1 to 4 is approximate to 6.
What is it? The definite integral is represents of a specific rate of change. It represents the accumulated change over a given interval. The definite integral is nothing but the limit of the upper sum and the lower sum as n equal to infinity.
Formula. First, you have to write the integral, the b and the a. It's always the same. Now we have a f prime, x, dx, and a little equal. Then you have to write the f lower, b minus fa. But it's to say that f prime, it's always f lower. But the correct way, it's always put first the f prime equal to f lowers.
So, we already know that the integrals, they have many solutions, and in order to find the final result, you may take a path or another. It doesn't matter. But the thing here is when we talk about definite integrals, we all know that the integrals may have different ways to solve them. So in order to solve a definite integral, it is really important to take out the constancy out of the equation. Otherwise, it will be an indefinite integral. So the thing here is that your function evaluate it in your different limits, you need to take the area above the x-axis minus the area below the x-axis. In that way, you will eliminate in a certain point the constant c. And that's what we want, because you will have your result of your total area. So that's pretty much it. Thank you.
So today I'm going to explain you how to develop a definite integral. So first we have our function here, which is 12x squared, and we're going to find the antiderivative. And first of all, we're going to integrate. So we put 12x squared, and we're going to apply the formula. So we add 1, and in the part below we do the same. So we get 12x to 3 over 3. So here we have our function integrated, and we're going to simplify it in order to have a simple one. So we divide 12 over 3, which is 4, and we obtain 4x to 3. So here we have our, so we have it here simplified, and we're going to start to apply the fundamental theorem, which is the superior limit minus the lower limit. So we're going to start. So we have here our limits, the superior and the lower limit, and we're going to start to substitute them on the function. So we start with the superior limit, which is 2 here, and then we start 4, and then we change that x for the 2, and we 2 to 3, and then we add a minus sign, and then we do the same but with the lower limit. So 4, and we substitute the x for 1, and that's it. So we start to do the operation, which is 2, here we get an 8, and here we obtain 1. So let's put
32.
So we get the result. And this is how we do a definite integral.
What is related to sums of Riemann definite integrals? Well, definite integrals represent the exact area under a given curve. Riemann sums are used to approximate those areas. However, if we take Riemann sums with the infinite rectangles of indefinitely small y using limits, we get the exact area of the definite integral.